Hey everyone, we're going to get started here in a few minutes. Give me a mic check. Give me a thumbs up or something in chat if you can hear.
Check 1, check 2.
That's right. There you go.
Talking to the
Excellent,
microphone, Joe Dirt.
Yeah, we're going to give it a few more minutes and then we'll get started. I appreciate the people that are in person and not sending their note takers to summarize this. I've been on some webinars where, yeah, it's more note takers than people. All right, one more minute and we'll get kicked off here.
I was going to send Mark Click to be my note taker, but he's not here yet.
Yeah, what's up with that? Mr. AI, huh?
He'll be on shortly. I just talked to him.
Yeah, good. And this is being recorded, so we will share the recording afterwards so everybody can share it, consume it, watch it again, etc. David, go ahead and kick it off.
All right, guys. My name's David Shear. I am the owner of a technology advisory company called Shear Intelligence. We are strategists and connectors of people. And one of the ways that we connect with our customers is through connecting them with other people in the industry through education events like this webinar. Today we have George Danner from Business Laboratories. George is a data scientist for hire. He's written 2 books and travels the world giving talks just like the one you're about to hear. George?
Okay, well, thank you very much, David. And I'm joined by my colleague, Jeff Hara here. And good morning, everybody. Welcome to AI in manufacturing. We get to talk about my 2 favorite subjects, AI and manufacturing. In full disclosure, I just want to let you all know that early in my career, when I was a young engineer, I was a factory automation engineer for the first 13 years of my career. So my job was to crawl through dirty, smelly, noisy, dusty factories and figure out how they worked, and then write software to figure out how to make them work better. So manufacturing is very close to my heart, and I still do some of that work. I still tour lots and lots of factories these days and learn a lot about how all kinds of things are made. So welcome, everybody, and I'm glad you can join us. I'm going to make some assumptions about some of you here in the audience. The assumption is that you're all along the spectrum. There are some of you who maybe yesterday learned to spell AI, and there are others of you who have been applying it for quite some time, maybe are doing some projects and programs around AI, fairly experienced with it. And what we're going to try to do is appeal to everyone in that audience, regardless of your level of skill and experience here. Sean and David thought it was important to sort of get out there in the public domain some discussions about this very important topic. I mean, every manufacturer on the planet, at least all the ones that I've talked to, are today under relentless pressure to be better, faster, and cheaper. And in fact, your reward for, say, being 10% better last year means congratulations. Now you got to be 20% better the next year and 50% after that, and so on. So you've all done the normal traditional things. You've done Lean and Six Sigma and you've cleaned up your processes, and you've done all of that, and that's great and noble work. Congratulations. But now we're talking about, okay, how do I squeeze even more? Even another 5, 6, 7, 10% out of my yields. We're going to talk about that today. Increasingly, the answer to that is the more nuanced strategies of using data and analytics to make our manufacturing systems better. And oh, by the way, we are talking about manufacturing this morning, but I also want to say that there are some of you out there in the audience who are not manufacturers, but have joined this webinar because you're generally interested in the topic, perhaps interested in AI. There's content in here for you too, because one of the things that we at our company sort of think about is that every company out there is a factory. Now, you may be a bank, you may be an insurance company, you don't think of yourself as a factory at all. But when you step back from your organization and sort of think about things like throughput and cycle time and rework and all of these kinds of things, all of those have their peers in your business, whether you're a traditional factory or not. So there's some things that you can certainly learn from today, whether you might be interested in. AI is a very sort of confusing domain right now. You're hearing a lot of hype, and you read a lot of things every day in the news, and about half of it, in my estimate, is not real. About half of it is. So how do you distinguish between the two, and how do you move forward? So we're going to kind of start that process today by giving you some ideas of what it looks like in the trenches to apply AI. Okay, so the first thing that I'm going to talk about is that AI for manufacturers is really an extension of things that you're already doing. So good manufacturers are very process-oriented people. You look at processes, you possibly document them. You are process-driven because that's just the nature of the beast of running a modern manufacturing system these days. Well, that is actually a great precursor for AI, and here's why. There are AI projects along a spectrum, and one end of that spectrum is the big splashy enterprise-wide AI project. The CEO comes in, makes this big announcement, you pull teams together, we're going to do AI, and that's on one end of the spectrum. And quite frankly, I'll tell all of you, I have never seen the big splashy giant projects actually work. They usually get crushed under their own weight. What I have seen successful is things on the other end of the spectrum. Tiny surgical doses of AI in just the right places that give this magnified, amplified effect. Those do work. So how do you know where to inject AI in these surgical doses so that I get that effect and I'm not just sort of wasting a lot of money and resources on implementing AI because some command sort of came down from on high? Well, the way we do that is we do, again, things that you're already doing. We build diagrams. Let me say that again. We build diagrams. Diagrams are the language of systems. And increasingly, diagrams are the platform by which we talk about our organizations and share between ourselves who are out there just trying to run these manufacturing organizations and technologists who have a good, deep understanding of what AI does and can implement that. The language between the two groups, which are often different people with different skill sets, the language is a diagram. the metaphor I'll use is like your car. You know, if you were to wheel your car into a room and we're all sitting around talking about your car, you know, we can only go so far with that conversation. I mean, we can look at a hunk of metal and it's got tires and yeah, there's a steering wheel there. That's all great. That's about as far as we can get in the conversation. However, if we were to reach in the glove box and pull out the owner's manual and flip to the very end and look at the schematics of the hydraulic system and the electrical system and the propulsion system and so forth, okay, now we can have a much more meaningful conversation about that car and how to make it run faster or run with better fuel economy and so forth. The same principle applies in business. We use schematics, we use diagrams to talk through how a manufacturing system works and then ultimately get to the idea of these small surgical doses. Another analogy I'll use is like an X-ray of a patient. You go into your doctor and you say, you know, my back is hurting, or you know, my knee won't turn, or something like that. One of the first things the doctor will do is take an X-ray of you and look at different parts of your body and say, okay, I need to inject some medicine right over here, and maybe I'll inject some more medicine right over there. And that doctor will do that based on that X-ray and the understanding of what's inside your body based on that X-ray. These diagrams that I'm talking about, and I'm going to show some examples here in a moment, these diagrams are the equivalent of an X-ray of a business, really any business. Again, could be a manufacturing business or not. The same principle applies, that diagrams are the means by which we get into the salient details of a company and how it's wired together, how it's built, and how it might be wired differently in order to make it run better. Now, let me give you an example of, in fact, a manufacturer that we worked with recently. And I am now sharing my screen, and I'm hoping, you know, I get a thumbs up. Yes, I can see that screen. Thank you. Thank you very much for that. Of a company that of all things, they make hospital beds. Really doesn't matter what they make. Manufacturing has a lot of similar patterns. They just happen to make hospital beds, and they do a great job of doing it. They build them, they make them, and they manufacture them, and then they rent them out to hospitals. It's a darn good little business that aspires to be better. But one of the things that they brought to us was this idea that our sales and inventory and operations planning process was broken. And I said, well, how is it broken? And they said, well, maybe it's Johnny, or maybe Sue is not doing her job, or maybe this, maybe that. I mean, I was given all these sort of pointing lots of fingers all around the manufacturing system. And I said, okay, I need to understand what's going on. The SIOP process, all of you are out there who run manufacturing businesses, you're very familiar with this. You run your MRP systems to figure out, based on demand forecast and what you have on hand in inventory, and you know what's recently sold, how many parts units to manufacture the next period given the delivery schedules, etc. All that is part of SIOP. If SIOP is running in a healthy way, you've got a healthy business. If it's not, you don't. So my first job was to break apart the SIOP process. Now, that diagram that you're looking at, it's going to be very tiny on your screen. You may not be able to see all parts of it. Don't worry about that. Our purpose here is not to go through every little bit of this diagram, but to simply show you that we have conversations with our experts as they run these manufacturing systems and how it works, how it's put together. And then our job is then to translate what an expert says. These experts are also often called SMEs, subject matter experts, SMEs. We talk to these SMEs, and then our first job is to then translate that into diagrammable form, if you will. This happens to be one particular page out of out of that the set of diagrams that I built of this company. So my first job was to take this equation, which nobody had ever written down. Imagine that. Nobody had ever actually drawn it or written it down, and splay it out so that it then could be viewed and critiqued and discussed and so forth. So what you're looking at is a diagrammatic representation of SIOP for this company, which naturally led us to the idea of our workflow. Again, every company has a workflow, some of them complex, some of them not. Many of you have probably built process flow diagrams. That this is not one, this is a schematic, this is a systems schematic, so we use a slightly different method, but the idea is the same, which is to take somebody take a system and really start to break down its salient pieces. Again, just like that analogy that I was using earlier, which is this X-ray of the patient. This is an X-ray of the business, and I ended up building quite a number of these diagrams in increasing levels of detail. Notice I'm drilling down in increasing levels of detail into what's going on here. Now, what we often are confronted with, and this is particularly true in manufacturing, is that human beings, know a lot about how things are made and their particular piece. Maybe their piece of it is running a particular machine in the workflow. Maybe their piece of it is scheduling. Maybe their piece of that is order fulfillment or inventory. They have spent years and years in that domain. They know every little salient part of it, but what they may not be good at, and usually aren't, is writing down what they know. We have come in recent years to call this Michael Jordan paradox. So Michael Jordan, arguably the greatest basketball player that's ever lived. Maybe I'll get some arguments there. Great basketball player. And if you throw him a basketball, he will take that ball, he'll dribble it down the court, and he'll make the most beautiful layup you have ever seen. And then you sit Michael down afterwards and you say, okay, Michael, how did you decide to, pass the ball from your right hand to your left hand? How did you decide to move this way versus that? How did you decide when to jump and what foot to use to jump? You could ask him all those questions, and he probably won't even be able to give you an answer. He'll say, well, I don't know, man, I just do it, because it's been ingrained in him, that muscle memory, over and over again. In business, it's the same way. We have people who do great work, they've got great knowledge and great experience, but it's all sort of contained in human brain matter. And the challenge when we start to talk about AI and how do we layer AI in appropriate ways across a manufacturing system that's running really well, that you want to make run better, how do we do that? The first challenge that we're confronted with is taking these people who are experts in their field, asking them deliberate questions, and then documenting in this sort of way that I'm sharing with you now how something works. So it's a translation exercise. So I know it's kind of counterintuitive maybe to many of you, which is, hey, how do you make best use of AI? Often you set the AI aside as the first step, and you do good sound practices with what are my processes exactly. Now, some of you do this kind of work, the kind of work that I'm sharing with you here, and you have your processes very, very thoroughly defined and diagrammed. Some of you need help in that regard, fine. But the point of the matter is that this diagramming is the basis upon which we apply AI to make sure that we're not just broad brushing AI in places where it just doesn't belong. In my experience of using AI, and I've used AI since 1986, in my experience, I've seen a lot of misapplication of AI, overinvestment in AI. And it's because we didn't start day one with this sort of process level understanding. Fortunately for you manufacturers, processes are part of your DNA. And so if you have done this work, or if you started this journey, or if you have people who even just have it in their heads about how processes work, you're already ahead of the game when it comes to AI. All right, so a lot of the things that we've done often in the AI world is to go the next step, which is, okay, I've built my processes, and I've actually employed, things like operations research to understand how those processes work, to sort of put them in motion, bring them to life. So some of you might have even gone to the next step of simulating some of your processes. And so what I'm sharing with you here is what the next logical step would be after you do those static diagrams. Those essentially form the blueprint then for simulating your manufacturing environments. So this is a whole bunch of simulations that we've done in our past. Some of them are manufacturing, some of them are not. But the idea that we bring from the world of operations research, which is heavily steeped in manufacturing, that's really where operations research grew up. We simulate things. Now, why do we do that? We do that so that we can ask what if questions about our factories. What if we added a new product line? What if we took on this new customer that has this slate of products? What if we took machine number 12 out and put this other machine in? What if? You've got all kinds of questions all the time about how to better your manufacturing systems. Simulations are the way to do that without physically experimenting and possibly making a mistake with that system. These are often known as digital twins, the digital twin of a real system. So what we do is we take a real system, create a digital replica of it, and then experiment with that replica, gain insights as to how it would work and could work, and then use those insights then to layer onto the real system with the confidence now that it's been vetted in the digital world. You're not just experimenting on a whim. You have verified that, hey, yes, this change is going to give me a return on my investment or speed up certain processes and so forth. We do that with simulations, with these digital twins that we have at our disposal. So many of you, again, are already doing a lot of this kind of work. So when you joined this webinar, you may not have realized that you're already laying the foundation. Congratulations. You're already laying the foundation for AI in your organization. Okay, let's say you've either done that or you're on the precipice of doing that. Great. Now the question becomes, okay, where precisely do I put AI? How do I know, just like the doctor knows to inject just this right dose of medicine in just the right place in your body? How do I know that when I go to my manufacturing system? Well, often the diagrams, much like the diagram I'm sharing with you here, provides clues as to how things are going and where to apply. Do you notice in this diagram, for example, I kind of zoomed out a little bit. Notice the little red dots here? Those red dots are structural places where in the manufacturing system that it's drawn our attention. So this might be a place where there's lots of manual handling, where there's lots of human expertise, there's no automation, where there's lots of rework that we've seen, where there's lack of sort of important feedback loops that are governing the manufacturing system, there are these structural clues that we've learned over the many, many years that say, hey, AI might have a role here. And so we place these red dots in the right places, and we try to understand what's going on. A lot of the companies that we work with are an algorithm or two away from greatness. So they have a company, they have a good company, they're running a manufacturing system, and let's say your KPIs are actually pretty good. Well, sorry, that's not good enough, because the owners of the assets are saying, no, more, better, faster, cheaper. So we have to look to these places where we can apply advanced analytics, AI being one, to give us a better outcome. Okay, so what's an example of these red dot areas where we might apply AI? So I'll give you an example from something I did just a few weeks ago, and my colleagues who joined me understand this example very, very well because they've been part of it. But I was part of a company, working with a company that was a food manufacturer, a food ingredient manufacturer, and they sold their food ingredients to some very top, very recognizable food brands that, if I were to say them, which I'm not, you would all recognize them. So they had a hard job. They had to make these food ingredients week in and week out under very strict schedules. They had on-time delivery targets that they had to meet. These brands, these famous brands, were very demanding in terms of quality, in terms of speed. That's a hard job. So how do they do it? So I created diagrams very similar to the one you see here. And one of the things that we noticed was their scheduling. So they schedule their batches of product. They basically take these food ingredients, they take agricultural products, crops, and put them in this gigantic vat, heat it up, add some water, add some other ingredients, and then package it. That's essentially their process. They do that on a batch by batch basis. So they'll make product A, and they'll run that for a few days, and then they'll make product B, and they'll run that for a few days. Many of you who are manufacturers understand the concept of a product wheel. They were doing that. They have a product wheel in place, and they do that, and they have rush orders that come in. All that was scheduled manually. That was scheduled by a human. And so I sat this human down. I said, how do you do this? How do you schedule this? Well, okay, I consider this and I consider that. This person, this gentleman, went through a list of 24 different factors that he had to consider to figure out which batch of product to make at a given moment. If you get that wrong, if you make batch A before batch B or B before A, and that wasn't the inventory item that was called for, and things happen, then your profitability, and they had very thin margins, their profitability was decimated for that particular week. So this particular process had a high degree of manual content. It had a high degree of tacit knowledge. We sometimes call it voodoo. This poor guy had to know all the voodoo. Oh, never use this product with this particular ingredient. Always do this. Never do that. Always do this. All these rules in his head that he had to learn, because the previous person had spent 18 years or so doing it. He had to learn from that person. All those rules were in his head. I pray for this company that this person doesn't get hit by a bus one day, because all that knowledge is going to go out the door if he gets hit by a bus, or if he leaves the company, or if a competitor comes along and hires him away for whatever reason. So these kinds of clues became very evident to us as we were putting together the diagram similar to the one that you're seeing here. So one of the things that we said is, well, gee, this is one of those kinds of things, algorithms, if you will, that is a strength of AI. AI can consider all these sort of crazy rules. If it's, the third Thursday of the month and it's a full moon, always do this kind of thing. We run into that tacit knowledge, that legend knowledge all the time. Most of it is never talked about, never discussed, never written down on a piece of paper that we have to extract out. But those are the rules that run this company. And so taking that out of a human hand and putting it, and by the way, this gentleman created a schedule on a spreadsheet, and then handed that to the production supervisors, who then sort of carried it out shift by shift. Now, I'm sure none of you ever put really, really super important information and data in spreadsheets, do you? It's okay, don't raise your hand. But we see this sort of over and over again, using spreadsheets for more than they were really intended, basically building models in spreadsheets, which are more than spreadsheets were intended for their purpose. That's another sort of clue that said, ooh, something's going on here. AI could play a role in this. So we have a very important process governed by a lot of tacit rules that has to use a ton of data, has to be almost omnipresent and all-knowing, all-seeing. This scheduler god has to be all-knowing and all-seeing in order to create a profitable week, 4 weeks out, which is typically how they schedule. That is a perfect candidate for considering AI. So that got a little red dot, and now is undergoing the process of saying, okay, so if we build an AI agent, what is it going to consider, and what kind of human knowledge needs to be brought to bear in order for AI to do as good or better job than the human counterpart. And what that will do, they're not going to fire the scheduler. What they're going to do now is have AI rule that domain and create a draft schedule that then the scheduler can take to the production supervisor. They can discuss it. They can overrule it, override it, and say, no, I really think this batch should go before that batch. Fine, they can do that if they wish. But instead of being embroiled in the mechanical aspect that is not adding value of creating the schedule, but interpreting the schedule wisely, doing what humans do well, which is pattern recognition and analysis, that now is what the scheduler, that's the scheduler's new job. So again, for all of you out there who are attending this webinar, that's an important concept for you, which is everybody has two jobs. You have the job that you have now, which consists of a lot of sort of mechanical, rote, repeatable kind of tasks. And then the job that you aspire to have, which is the thinking job, the analysis job, which you don't usually have time to have. My experience in watching a lot of manufacturing systems is everybody there is fighting fires all the time, every day. You're fighting a fire, you're solving a problem. And in fact, you probably get rewarded for fighting fire. Oh, congratulations, John. You avoided that disaster. Here's your bonus. That's rewarding something that shouldn't happen in the first place. We should be spending a lot more of our time on some of the analysis and interpretation tasks. This is what humans do really, really well. Now, you read, I'm sure, every day a whole lot about how AI is gonna create mass layoffs, and we're gonna fire everybody and run all these companies with one or two people. I am extremely skeptical about these kinds of prognostications. Rather, I think what's going to happen over the next decade or so, I can't see beyond that, but over the next decade it's gonna be more one of an economy that is driven by humans who are doing more human-like tasks. And human-like tasks are thinking tasks, not mechanical tasks. So AI doing its job well is going to take a lot of that burden off of the shoulders of people and do the good thing, which is relieve them of the burden of things that humans really shouldn't have should be doing in the first place. So as a person, I'm very optimistic about the future. I don't see scenarios that involve a lot of mass unemployment. A lot of the mass layoffs you're seeing really don't have a lot to do with AI. That's you're being fed a bit of a false narrative there, I believe, but rather it's the productivity equation. Most of the leaders that I see, leaders of manufacturing businesses, don't come in and tell me, "Hey, George, I want to fire a third of my staff." Rather, what they tell me is, "I want to take the same people I have and do twice as much as I did last year, next year. And the year after that, I want to do 3 times as much. And the year after that, I want to do 5 times as much." That makes the people that work for you more important, not less. So I really don't, you should have a very skeptical view on all of these people who are saying, "Oh, we're not going to have any doctors in 5 years because they're all going to be replaced by AI." That's just, I just do not believe that's going to happen. If some of you want to get with me offline and ask me why I believe that, I can give you both economic theory and statistics that will sort of back up my point of view. But the overall point that we need to draw from that is that the great challenge before us is sort of reinventing work in the way that I just described, and that is taking these rote mechanical tasks off of humans, automating those to a large degree, so that a person can have a brand new job, which is the thinking equivalent of that job that they had before. Now, I'm going to open this up to questions, to more questions. I want to leave a little time at the end of the questions, but I want to cover one other topic around AI and manufacturing before we conclude here, and that is the use of AI in creating the simulation models that you just saw. I ran through a bunch of those animations. Those are simulations that we've built. So where does AI play a role with simulation? So we at our company have been engaged in, well, let's call it an R&D effort for the last year or so, because we asked ourselves, could AI take salient information about a company, like the diagrams that you're seeing, like data we gather, like interviews we do with SMEs? Could it take all that information in total and create a simulation model like the one you just saw? We said, that's a challenge question. Could it be done? So we created a fictitious business that is in the lemonade business, not lemonade stands, but producing lemonade. We said, okay, let's create this fictitious business. Let's give AI all this information about its sort of financial dimensions, its operational dimensions, its processes, anything that we would do for a real company, we did for this fictitious company. And we essentially turned that over to AI. In this case, we used Claude from Anthropic. And again, offline, if you want to know about the different platforms and their strengths and weaknesses, happy to talk about that offline. I don't have time to do that this morning, but I can talk to you about that offline. So we gave Claude, in this case, all the salient information, and it wrote the code to build one of those simulation models that you just saw. We then asked it, okay, can you build a visualization? You notice all of those models previously had a visualization component. So if we're looking at a factory, it's as if you ripped off the roof of the factory and sort of peered inside. You can watch the widgets, go back and forth from raw materials through their various plumbing, ultimately to get to finished product. It built a visualization for us, and it did so brilliantly. We then created skills. Now, Claude in particular has something called Claude Skills. And what that is that's a way to sort of coach AI into doing something you want it to do. Giving it pointers, giving it tips, giving it techniques. So we essentially created a document or a set of documents that said, here's how models are built, and here's best practices that we've learned over the years. David earlier mentioned I wrote a couple of books. So we had it sort of consume important points out of our books and say, hey, okay, here's some tips on how to build those models. And it dramatically improved the model's ability to create those models, created them in an error-free kind of way. So that was a kind of a stunning accomplishment that AI could actually write code to build those models. An important piece of that too is the security side of that, and the workflow side of that. If you ask AI to optimize something, optimize a factory, hey, tell me the optimal raw material inventory I should carry next week, it's going to really struggle. Even the best AI, it's going to really struggle with that. But what it will do is it will write code as a model to answer that question. That's really beneficial to you from a security standpoint, because now that model you can run and you're not exposing that model to all these AI platforms. There's a lot of concern that, I'm sharing this all stuff with OpenAI and with Anthropic and with Google and with Microsoft. I don't want to share all my important data. Well, one way around that is to get AI to write some code, and then you can run the model locally, and the AI platforms don't even have to know how you run it or what data you use to run it. Again, that's a wider topic that I'm happy to talk about. So in our experiment, we were able to get AI to build a model for us. And again, for those of you in the audience who are looking to model your processes, this is a way to do that in a very rapid fashion. Now, the next challenge, which is kind of the more important challenge, is could we get AI to run the model for us? In other words, could we bolt AI to this model as kind of like a front end? And instead of having to know exactly what parameters to change and what sliders to slide and what dials to tweak, can we just ask an English language question of this model and get AI to run the model for us with all the right data? Okay, there's our challenge question. So we started experimenting with that, and it did so brilliantly. Not only did it give us answers like what's the optimal inventory, and what production rate should I use for machine number 3, and these kinds of things. It answered our questions very thoroughly, provided KPIs. Hey, if you do run it this way, here's your your throughput, your yield, and your attainment fraction, and your profitability, and so on and so forth. It gave us the whole rundown on the stats based on the question that we posed to it. So AI is now serving a role in running the model. Sometimes it ran the model several times and compared run cases for us in order to answer the question that we posed. And again, we gave it a Claude skill to make it an expert in running the model. So we gave it tips and techniques on how to run the model. So now it's running this model for us and responding to just these English language questions, which was stunning to us. So we said, this is amazing. So we noticed when we were running one of our lemonade production experiments that it gave us all the stats on some experiment we ran. And at the very bottom of the prompt there, it said, hey, by the way, I think your profit would increase if you ran a second reactor. the reactors that make the lemonade. And my colleagues and I just kind of like looked at each other and said, wait a minute, we didn't ask it to do that. We never suggested that there could be a second reactor. We never gave it that clue or never asked it that question. And it came up with that on its own. And so it asked us, do you want to run a simulation with a second reactor? And so we said, okay, yes, click, run it. It ran it, and it gave us an extra 6% profitability on top of the best run we had done there before. Now, I'm going to tell you folks that I've been working, as I said, with AI since 1986. It takes a whole lot to impress me about how these systems run and what they're doing these days. And that was a jaw-dropping moment for us, that AI not only could analyze a manufacturing system by serving this role as a front end to an important model, but it could actually suggest things about ways to analyze the manufacturing system that we had never even thought of. The serendipity effect, this is often called. So these AI platforms are getting much better at helping us think for us and things for us that we never even came up with. So I'll close there, giving us sort of 10-ish minutes remaining, and allow you all to ask whatever questions that you like. We'll open the floor up to questions. You can ask your questions, I believe, by unmuting yourself. Sean, I think they can unmute them. Okay.
Yes.
You can unmute yourself, ask a question, make a comment, whatever you like. I'm going to kind of open the floor and let you ask away. Like I said, we've got about 10 minutes remaining to do that. So I'll pause and turn it back over to you, my audience.
Yeah, if you want to raise your hand or type it in the chat, we can accommodate either one. I see John's typing a little bit. You might have a question. You see that question, George, or do you want me to read it?
Yeah. So John Bennett asked the question, and you all see it, but I'll read it back anyway. George, what do you see as the biggest challenge in manufacturing regarding AI adoption? I've heard this sort of AI adoption challenge before, and it's amusing, to hear this. This is always like a challenge, right? You've got people who have worked in systems. They're sort of immune to change. I want to keep doing the same thing I've been doing for 20 years. Don't come at me with all this sort of change stuff. And sure, there are ways to increase AI adoption, but frankly, one of the best ways to enhance AI adoption is to avoid adoption altogether. Some of the best AI is AI that works invisibly in the background. You don't even really know it's operating. It just does its work without you prompting it, without you using it. It just does its work. Back to my scheduling example for the food ingredient manufacturer. That is, we haven't built it yet, but that is when we do, it's basically going to run a schedule and give you a draft of schedule and email you every Monday morning or whatever and say, hey, Joe, here's the recommended schedule for this week. And so that's just going to happen. There's no adoption or anything. It just happens. So most of the AI that we're working with these days doesn't rest on, a hope and a prayer. Gee, I hope my people, will adopt this. I hope my people will use these software systems. We just bypass that altogether and make it run in the background. That may not have not been the answer you were looking for, but that is one of the best ways to do that. Thank you, John, for that question. Any other questions?
Questions, comments, anything?
Yep.
Who wants more?
All right. Question from my colleague, Jeff. That's not fair, Jeff. asking questions, but here he says,
not really a question.
if you'd like to talk to us more depth about what it would look like to develop an AI strategy at your company, fill out this short form, start a conversation. Okay, yes, and I'll address the AI strategy piece too, because Jeff raised an important point. Often we get phone calls. We get phone calls all the time from all kinds of crazy people all over the world. Hey, George, can you come help us develop an AI strategy? And that's great. You know, a lot of sort of senior leaders are being tasked by their boards to say, you know, Mr. or Ms. CEO, where are you using, you know, AI? And so now the CEO is going, oh my God, we got to use AI. So he turns to his people and says, okay, you know, where are you using AI? You know, let's cram AI wherever so that I can go to my board and tell them we're doing a great job. So it's a legitimate question about AI strategy. And I'll give a short answer. And again, using Jeff's form, if you've got something specific to your company you want to talk to us about, we're happy to do that. And that's a convenient little form that you can do that. But in general, I call it the sine wave strategy. So you've all been subject to the gold standard consultants, you know, wingtip shoes, you know, walking in and, you know, $1,000 suits and saying, okay, you know, I'm the smartest guy in the room. You know, here's the 10 things you need to do. Thank you very much. And here's my invoice. I've seen that over and over again. And these gold standard consultants, which I'll never name, McKinsey, will come in and will tell you, you know, these things. And that's it. That's your AI strategy. I think that's a very weak strategy because it's not born in the reality of how a particular company works. So what we do is we do something called a sine wave strategy. So like a sine wave goes like this, right? And a sine wave strategy says, sure, I'm gonna impart some principles and some theory, but then I'm gonna follow that sine wave downward and I'm gonna build some stuff. I'm gonna build some pilots, I'm gonna build some actual projects, I'm gonna build some stuff that is that manifests that theory. And then I'll come back up and improve my theory, go back down and anchor it to the real world, come back up, prove my theory again, and so forth. Constantly oscillating between theory, which is important, and that's good grounding, principles are important, and you know, this is really how the company works. That balance is what we're seeking. So an AI strategy comes about going through, I don't know, 2, 3, 4, 5 cycles of the sine wave, then you've got a good strategy. That's typically how we like to go about it. Okay, so thanks, Jeff, for raising that point. Any other questions out there? We've got a few minutes left to get your licks in.
Yeah, I think a great starting point is just doing a workshop, right, with George in a company and kind of meeting those stakeholders to flush out a lot of those theories and information within the company. So yeah, that's a great engagement. Yeah.
Yes, and you know, it's kind of like not very expensive to do something like that, and yet it yields the highest rewards because you're basically defining what problem you're solving. You're de-risking it because you are being very deliberate about the data you're going to use and which problem you're solving, and by definition, what problem you're not solving. So that's like the best money you could ever spend is doing this sort of front end workshopping, like Sean is suggesting here. That's really important, and that's the prudent step that most of the companies we're seeing. That's what they do before they invest directly in the building of some AI agent or collection of agents.
Yeah, we in this market that we've seen, and you know, I've been working a lot of the mid markets, you know, that you know, privately held companies, they just can't afford to get it wrong, right?
Absolutely. Because
their margins are thin. You know, they're not you know, Humanas and the Fords and you know that big where they, you know, the 7-8 figure check is just an rounding error for them, right? So yeah, this is a good way to flush out real real information, real conversations, and real ROI at the end. What they're always
Yes,
looking for.
solving real business problems and not just
Correct.
a science experiment. Yes, absolutely, Sean. You're absolutely
Well,
right.
Well, excellent. I think if there's no more questions, we're going to wrap it up. David, you have anything else?
I was just going to add that what I love about George's approach is that he walks into a noisy AI environment where there's so much chaos, uncertainty. Where do I start? Where do I begin? And makes it quiet and gets you to a point where you know where to start with AI and you're confident that the outcomes are going to be what you want and you know that the ROI is going to be there.
Excellent. Excellent.
Great. Thank you, David. And I want to thank the audience. Thank you for staying with us. I hope this was a valuable use of your time. We'd love to hear from you. If you liked it or didn't like it or have suggestions or recommendations, we would love to hear from you. So thank you for hanging in with us for this hour, and I hope you found it well worth your time.
Appreciate everybody. Reach out if you need any more. Thank you.
Thank you.
Bye-bye.
Thanks.
Take care.